We're going to be going over derivatives as well as the first principle of differentiation and how we could apply this principle to find the first order derivative of a certain function. Starting off with derivatives. Derivatives are simply a measure of the rate of change of a given variable with respect to other variables. For example, when we measure the rate of change of distance with respect to time, we recognize this as velocity. In math, we usually measure the rate of change of our function f of x with respect to the variable y. So we could say the rate of change of f of x with respect to our variable x. Now, the first principle of differentiation offers us a way and method so that we could solve for the first derivative using a limit. Now, as you can see on the screen, the first order differentiation of the function f of x equals the limit as h approaches 0, and in the numerator we have the function f of x, plus x plus h minus the function f of x over h. And by solving this limit, we will obtain the first order derivative of f of x. Let's do an example to better illustrate this. Our first function is given 2x minus 3. Now, let's solve for x plus h here. And to do so, we simply replace the variable x with x plus h, and we expand and simplify. So, in this case, f of x plus h would simply be 2 multiplied by, open brackets, x plus h minus 3. And if we expand this, this would result in 2x plus 2h minus 3. Now, to find the first order derivative, we would simply have the limit approaching 0. And now that we have f of x plus h, we write this expression in our numerator. So 2x plus 2h minus 3, and don't forget we have to subtract this from our original function, so minus 2x minus 3 over h. Now if we apply the value 0 to our expression, we would have 0 in our denominator, and that's not acceptable. Therefore, we have to further simplify this so that we could solve our limit. Now, if we look closely, you could see that we have a minus 2x and a plus 2x, which could cancel out with one another. And then if we multiply this negative with our negative 3, it would result in positive 3, and the negative 3 over here and the positive 3 on this side would cancel out, leaving us with 2h over h. So I'm going to write this for the sake of not making it too difficult to understand. We'll have the remaining, after doing all the simplification, we will get 2h over h, and we could cancel these h's with one another. Therefore, the limit would simply equal to 2. And this means the first order derivative of our function f of x is simply the number 2. Let's do another example. In example number 2, our function is f of x equals 3x squared minus 2x. Using the same approach, let's first find f of x plus h. Again, we replace x plus h with the variable x in our original function. So we'll get 3x plus h power 2 minus 2x plus h. If we further expand this, we would get 3x squared plus 2xh plus h2 minus 2x minus 2h. And if we further expand this and multiply 3 with our expression in the brackets, we would get 3x squared plus 6xh plus 3h squared minus 2x minus 2h. And it's always good to double check if there's further simplification that can be done, but in this case, this would be it. Now, let's write our first principle. So the first derivative of f of x would simply be the limit as h approaches 0 of f of x plus h, which in this case would be this expression, and we'll write that here. So 3x squared plus 6xh plus 3h squared minus 2x minus 2h minus, again, as you see here, we have to subtract the original function. So in our case, it would be 3x squared minus 2x over h. And if we expand that and further simplify, we will see that we could reduce this expression in the numerator to be something much more simpler. As you can see here, we have a positive 3x squared, and if we multiply the negative with 3x, we'll get negative 3x squared. So this and this expression will cancel out. Furthermore, we have a negative 2x, and if we multiply this negative with our negative 2x, we would get positive 2x here, and this positive 2x would cancel with this negative 2x, leaving us with 6xh plus 3h squared minus 2h to be in the numerator and h to be in the denominator. Again, if we evaluate h at 0 at this point in our expression, again, we would be left with 0 in the denominator, which is not acceptable. So we could factor out an h in the numerator and rewrite everything as h equals 6x plus 3h minus 2. And we have h in the denominator. These two h's cancel out, and we could finally evaluate our limit as h approaches 0 within the expression 6x plus 3h minus 2. In this case, 3h would be 0 when evaluated at h approaching 0. Therefore, our first order derivative of our function would simply be 6x minus 2. And in this function, the next function, we have f of t equals the square root of t, for which t is greater or equal to 0. Now, if we write our first principle for this function, we would get, as the limit approaches 0, our f of x plus h, or in this case, f of t plus h, would simply be the square root of t plus h minus our original function, which is square root of t, and divided by h. Now, to further simplify this, again, if we evaluate it at h equals to 0, at this point, we would get 0 in the denominator, which is not acceptable. So we would have to rationalize this expression. And to do so, we multiplied both the numerator and the denominator by the square root of t plus h plus, this is important, plus square root of t. Same thing with the denominator. So it will be multiplied by the square root of t plus h plus the square root of t. And if we do this multiplication and rewrite our expression, it would be simply t plus h minus t h multiplied by square root of t plus h plus square root of t. Now, as you can see, our negative t and our positive t would cancel out, and in our numerator, we would simply be left with h. And we already have an h in our denominator, so we could simplify this further and cancel out the two h's. Therefore, our first derivative, as our limit approaches 0, would simply be 1 over square root of t plus h plus the square root of t. And now we could evaluate h at 0. And if we do so, we still have 1 in our numerator. H would be replaced with 0. Therefore, this would be square root of t plus the square root of t, or we could rewrite this as 1 over 2 square root of t. And this would be our first derivative of our given function. My apologies, I just realized that this is f of t, so do not make sure you know what your variables are when you're solving problems so that you don't get confused. But that would be all for today's video. If you have any questions regarding the first principle of differentiation, please leave a comment down below and I will do more examples on this topic. And don't forget to like and subscribe. Thank you.